when we start solving equations, typically we're going to have just one single solution. We solve the equation and we get an answer like x equals 2. Then we have one answer. The answer is 2. That's the only number that works. Or x equals -3. So -3 is the only answer that works. So that might look like if I have a problem like x plus 3 equals 12. I could solve this problem, -3 from both sides, x equals 9. It has one solution, and that solution is 9. That means that 9 is the only number I can plug in here for x that makes this true. Any other number, it would not be true. Only 9 plus 3 equals 12. But we have some other types of problems where it does not follow that. One example would be if I have 2x plus 1 is equal to 2x plus 1. We can reason this, whatever this number, this and this are the same, and this are the same. So because these sides are both identical, it shouldn't matter what number I plug in for x. I'm doing the exact same thing on both sides. I'm going to get the exact same number on both sides. So, but we can look through what this would look like if I were to actually solve this. If I were to actually solve this, I would do, maybe I would choose to do minus 2x on both sides. And that makes 0 here, and it makes 0 here. So my variable just completely disappeared. I don't have any variables left. All I have left is 1 equal to 1. Well, when is 1 equal to 1? 1 is always equal to 1. So this would be in all solutions, or we say infinitely many solutions. And I can check this because if it says all solutions, that means I can pick any number I want for x, and it should be true. So let's pick 5. So I'm going to plug 5 in for this x and 5 in for this x, because x is the same. X is x. So if I say x is 5, then it means all x's are 5. So 2 times 5 plus 1 equals 2 times 5 plus 1. This would be 10 plus 1 is equal to 10 plus 1. Does 11 equal 11? And it did. So no matter what number I'm plugging in for x, this is going to work because it is all solutions. That's what it means to be all solutions. I can pick any number I want for x and it's still going to work. On the other hand, if I change this just a little bit and I say 2x plus 1 is equal to 2x plus 5. So I kept the 2x the same. This one's still 1, but I just changed that last 1 to a 5. So again, if I start solving this, I would do minus 2x from both sides again. I notice once again, it makes 0 here and it makes 0 here. So my variable is gone, but now I have 1 equal to 5. But 1 is not equal to 5. 1 will never be equal to 5. 1 is 1 and 5 is 5. So this would mean that there is no solution. And we can reason through this too. 2x plus 1, if I multiply something by 2 and then add 1, if I multiply that same thing by 2 and then add 5, of course I'm not going to get the same answer. So this means that no matter what number I plug in for x, it's never going to work. There's nothing that's ever going to work. So an easy way to look is if the x numbers match, then you check the y's. If the y's match like they did here in this middle one, it's all solutions. If the x's don't match like this bottom one, then it's going to be no solution. Or like we had up top, where there's only one x, or another one, I could have 3x plus 2 is equal to 5x, and then it doesn't matter, this could be plus 2, or it could be 3x plus 2 equals 5x plus 7. It doesn't matter, because what is important here is that 3x and 5x, they don't match. 3x and 5x, they don't match. As soon as those x's don't match, we know that there's going to be just one solution, and then we can figure out what it is. You may also end up with a problem that's a little bit harder to tell. So if I had a problem like this, 2x plus 3 plus 5x is equal to, let's see, let's do 2 times 3x plus 1. So looking at this one right now the way it is, it's a little bit harder to tell. So we have to use some other skills we have. I can simplify the left-hand side. So if I simplify this side, I can combine 2x and 5x makes 7x. And then I have that plus 3 still. And then on here I can simplify this with distributive property. So that gives me 2 times 3x, that's 6x. And 2 times 1 is a positive 2. Now I have where I can compare, and I'm noticing right away this is a 7x and this is a 6x. Those are different. So as soon as I see those are different, I know that's going to have one single answer. I just don't know what that answer is yet, but it'll be one answer.